Hey class, this week we are going to be going over class relationships. This is when you create multiple classes in your programs, and these relationships are different ways that these classes can interact with one another. Before we get into the relationship aspect of it, I do want to talk about what a UML is. So a UML stands for a Unified Modeling Language. And this is pretty much just a schema. This is where each one of these nodes here represents a class. And then it's broken down by what members and what methods are in the class. And then these lines actually tell you what the relationships are between the classes. So in reality, if you worked for a company and your project manager would probably create something like this so that so that you could know what you guys were up against as far as the program. This would represent the entire program. Each of these would be the different classes that would need to be developed. Now let's go over the symbols a little bit. This first thing up here is the name of the class. Here are the attributes or the members. And then down here is where you would actually do the operations or the methods in the class. The attributes, so if you come up and look, you'll see like dashes and colons and all of that. When you break those down, they each mean a specific thing. The first right here is the visibility. If it is a minus sign, that would be private. If it was kind of a pound sign or a hashtag, that would be considered a protected class, or a protected attribute. And then the plus sign means that it's public for all to see. We haven't really gone over protected too much, but we've definitely gone over public and private. So be sure to take note of that. Then you have the attribute name. This is what you're calling that attribute. The type right here, so you do this colon, that's just to separate it out. And then you do the attribute type, so an int. So if you were to write this in code, you're saying this is an int named counter, and this is going to be private. So it's only accessible within the class. When looking at the operations or the methods, it's pretty much the same thing. You have the visibility, you have the operation name, but then you have parentheses. And within the parentheses, you'll have the name of the parameter, the argument. You'll have its data type, and then it'll be separated by commas. And same thing, the argument name, the type. And then way here at the end is the return type of the entire function. Now the reason why UML is this format is because it's not necessarily a C++ thing. UMLs are used for a variety of different programming languages. So they tried to standardize it, so no matter what the programming language is, you can look and kind of know what's going on. So you'll see some similarities with C++, some not so similar. But either way, you should be able to know how to translate this into C++ code. So here we'll show a UML example and then what it looks like in code. So in UML, you'd have this dash name, and it's of type string. That means it's private, and it's of type string. Here, it's private, it's type int, and it's named instance. Now this underline here actually means it's static, meaning it can't change, right? So if you were to translate this little UML into code, the access modifier would be private, string name, static int instances, or instance I should put, huh? There you go. All right, that's honestly all you need to know for UML. Pretty self-explanatory. So now we'll go into the different relationships in C++ within classes, and then a little bit of the UML as far as that goes. So the first relationship, and this is by far the most popular, so really take note of this, is inheritance. This is known as an is-a relationship. So what you do is you have a parent class, or the ancestor, or the base class, or the superclass. You'll hear all of these different terms. I look at it as parent and child. So you'll have your parent class, and then a derived child class. Okay? The parent is kind of the main thing, and then the child would be that sub-derived class. So when I say an is-a relationship, I'm saying a sedan is a car. A Labrador is a dog. Bob is a person. All of these are subsets or children of the parent. You can have many cars, but this one happens to be a sedan. You can have many dogs, but this one happens to be a Labrador. There's many people. Bob is just one instance of that. So you can imagine that when you create a parent class here, and then you create a derived child class, the way that the communication flows is one way, meaning the child will inherit everything from the parent, but the parent doesn't inherit anything from the children. So if you had a car class and then a sedan class, the sedan class would have all of the attributes or whatever the selected attributes are from the parent class, but the parent wouldn't have anything from the sedan class. Okay? The communication is one way. The parent cannot communicate with the child. Okay, so this is to reiterate what I just said. It's unidirectional, so the child can only send messages to the parent. It can access the methods and the attributes from the parent, but the parent cannot access the methods and the attributes from the child. So what does that look like in code? Well, you would have your class here, and I'm just calling it parent. And in here, you'd have all sorts of things, right? You would have your constructor, you'd have your methods, your attributes, your access modifiers. But then in the child here, this is how you name it. You call it class child, whatever that name is. You put the colon, this is the name scope resolutor, and then you put public and then the name of the parent. So if this was car, it would be class car. If this was sedan, it would be class sedan colon public car. Okay? This is how we say we want to inherit everything from the parent class in this class. Okay? That's called inheritance. All right, association. This is known as a has-a relationship. So a contractor has a project, and a project has a contractor, right? It's a two-way street. The communication goes back and forth, right? Contractors can have one or many projects. A project may only have one contractor, maybe more, one or many, and that's fine, right? So the direction, information goes both ways between the classes. So what does that mean as far as code goes? Well, the member variables are in each other's classes, and they have to be pointers. This is very, very important. And the reason why is, look at class 1 here, right? We're calling it peer 1. There is a pointer of type peer 2 pointing to it. And then in peer 2, there's a pointer of type peer 1 pointing to it. So since there's pointers pointing to each other between the classes, that means whatever I change here is going to impact this and vice versa, right? They are very interdependent on one another. What you change in one will affect the other. And that is known as association. So what does that look like as far as UML goes? The objects occupy distinct memory locations. So I mean, like, they are separate classes, right? But the objects point to each other still. And you need to make sure the pointers are easy to change. So the UML would look like this. You would have arrows pointing to each other like that. Okay, aggregation. This one's interesting. This one is a has-a or part of relationship. So has-a means it reads from whole to part, and part of means it reads from part to whole. So a little bit of a word salad, but basically, a car has a engine. The whole is the car, and the engine is a part. An engine is part of a car. Another thing you can think of is like a dog. A dog, the whole, a dog has a tail. It's part of the bigger whole. That's an aggregation. And the relationship here is you have this line, and then you have this hollowed out diamond here. So you'll notice that this car class has an engine, it has a transmission, all these different things. So yeah, so the UML, it builds the larger objects from the smaller objects. So you could have all sorts of these classes, and they all build this greater whole, right? They aggregate. They sum together to create the whole. and the diamond will always attach to the hole. So what does that mean as far as code goes? Well, you'll have a member variable in the hole, and the variable is a pointer. So this right here is the part, right? This would be the transmission or the engine. And then right here, class hole, this would be the car. And notice that we have a pointer of type part. So basically, whatever I change in the hole will impact its parts. But whatever I change in the part will not impact the hole. If I take out the engine, I'm not destroying the car. I'm just moving the engine somewhere else. Okay? So the part functions independently. So then what's composition? If you read this definition, it's identical to aggregation, right? The difference being the diamond, instead of being hollowed out, is now filled in. The relationships are the same. Has a reads from the whole to part, part of reads from the part to the whole. Engine has a car, or a car has an engine is part of a car. So what's the difference then? Well, with composition, the whole does not share its parts with other objects. The part does not exist without the whole. Okay? So before, when I told you with aggregation, the part exists independent of the whole. So if we got rid of the car, the engine would still be there. Maybe that engine needs to be put into a new car, right? But in composition, if the car is gone, the engine goes with it. When you get rid of that parent class, all the other children classes that are in it are also going to be eliminated. Right? So they're very, very similar, but that is a very distinct difference. So what's the code then? The code looks identical, except it's not a pointer, right? And it's not a pointer because if you get rid of the whole, the part would be gone, right? Other than that, it looks identical. All right, the last one is dependency. So this, you could easily say that one class depends on another class. In here we have a fraction class and a fraction calculator. Well, the calculator would depend on the fraction, right? If the fraction wasn't there, then the calculator couldn't be there. So they depend on one another. And you show this by having a dashed arrow. So the code here, it's very similar to if you call, it's just calling a class function into your class. So remember when we talked about friend functions and things of that nature, they were not members of our class, but we still called them. That would be a dependent relationship, right? So it doesn't matter how you pass it, by value, by pointer, by reference. If you're using another class in your class, they are now dependent on one another. Okay, that's all I have for this video. Please fill out that worksheet if you haven't already, the try it out worksheet that I have, where you fill out, these different relationships. We're getting close to the end of the semester, so get a head start on your final project, and please let me know if you need any help.